Okay, so we're going to be looking at analytical geometry today. And analytical geometry is actually geometry on a Cartesian plane. So we have here a Cartesian plane that I've set up. And we have 2 points. A is a point where x is 3 and y is 2. Remember, we always read off x first and then y. And B is a coordinates 7. X is 7. And y is 5. And what we're going to look at today is finding the length of AB. So we're looking at how do we find the length of AB. Now there is a formula to help us, but I just wanted to chat about how this formula came about quickly. And if we wanted to find the length of AB, we can't count it. Like if we had a line that was vertical or horizontal, we could count how many blocks it was going across. But with a slopey line like AB, we can't do any counting. So what we do is we imagine making ourselves a right-angled triangle. Okay, if we made ourselves a right-angled triangle, can you see that AB would be the hypotenuse of the right-angled triangle that I've made? Okay, now this point here, let's call it C, would have an x coordinate, here we go, of 7. See how the x is a 7 there? And it would have a y coordinate, let's look here, the y coordinate is 2. So the coordinates of C at that right angle there would be x is 7, y is 2. Okay, now we all know that using Pythagoras, we can find out the hypotenuse of a right-angled triangle. So because these lines, this one here, AC, is horizontal, I can count how many blocks it is, okay? So it would be 1, 2, 3, 4 blocks long, okay? Another way of finding out how long AC is instead of counting the blocks, would be to take the x value here, the 7, and subtract the 3. That would give me 4. Okay, so that would be another way of working out how long this line was. 7 minus 3. Okay, so this side is a 4. Here, this side would be 1, 2, 3 units. All right, and if I look at the y values, if I took the 5 and subtracted the 3, the two y values there, that would give, 5 minus 2, that would give me this 3. 5 minus 2 is 3. So a way of getting this vertical line here would be to subtract the y values. And then I could use Pythagoras. It's going to be 4 squared plus 3 squared. And if you know your Pyth triples, you'll already know that AB is 5. But if you don't know your Pythagorean triples, AB squared is 25. Square rooted, which gives me AB is equal to 5 units. Okay. Now, what we do is instead of using Pythagoras, we actually put it into a formula. So we say that to find the length of AB, we take the square root, just like we square rooted here, and to find the one distance, we take the x value at A minus the x value at B, and we square it. That gives us this distance. And then we add the the y value at A minus the y value at B squared. Okay, so if we use this formula, we're going to end up with exactly the same thing as this. It's just using Pythagoras. So let's just double check it. Okay, so let me just write these coordinates here. A is 3 and 2, and B was 7 and 5. So let's check. AB, okay, x at A, that's this coordinate here, 3, x at B, 7. 3 minus 7 squared. Y at A is 2. Y at B, 5 squared. Okay, so this is going to give me negative 4 squared plus negative 3 squared. And now that's going to give me 16 plus 9 square root of 25, which is 5. Exactly the same answer as here. Okay, so using this formula is just another way of using Pythagoras. It just means we don't have to draw all those lines. So we're going to remember that to find the distance between 2 points, we use a distance formula. And our distance formula is the length of AB is equal to the x at A minus the x at B squared plus the y at A minus the y at B squared. And if you square root that answer, you're going to get the length of AB. Okay, now when they say find AB like that, they might not say find the length, they might just say find AB. You must know this means the length. Okay, it means that you're finding the length of AB when it says find AB or find CD. Okay, so let's try an example using this formula. So let's take C is negative 5, 6. And D is negative 2, 1. And I want to find the length of CD. Sorry, that should be a straight line. That's a very bad line. Okay, so find CD. It means find the length. So we write our formula. Okay, so we go x at C minus x at D squared plus y at C minus y at D squared. Okay, and then I always write my coordinates next to my sum so that I've got them right here to put in, just so that I don't mess anything up. Okay, so just quickly, so you remember, so this is the x at C, and this is the y at C. This is the x at D, and this is the y at D. So those are what I'm going to be substituting. Okay, square root. All right, x at C is negative 5. X at D is negative 2. So be careful here. We've got to write minus negative 2 squared. Don't forget to substitute in a bracket like that so that we can make sure that we don't mess up our signs. Y at C is a 6. Y at D is a 1. And we've got to square that. All right, so you can put this whole thing in your calculator if you wanted to. I would prefer you not to. So this gives you a plus. And this is going to give you 5 squared here. Okay, so we have negative 5 plus 2, which gives me negative 3 squared, plus 5 squared. That's 9 plus 25. So CD is going to be equal to the square root of 34. Okay, if they said leave the answer in insert form, you would leave the answer there. If they didn't say anything, then you would change it into two decimal places, 5,83 units. All right, we can move these off to an application, so not just find the length. So we could have a triangle on a set of axes. So say C is negative 2 and 6, B is 5 and 7, and A is 2 and 3. Okay, so we want to show that ABC is isosceles. Remember, an isosceles triangle has got two equal sides. That's A and B. Find the perimeter. Remember, perimeter is the distance around the outside of a shape of triangle ABC to one decimal place. Okay, so now to show that ABC is isosceles, we are going to have to prove that it's got two equal sides. So we're going to find the length of the sides and show that they are, well, two of them are equal to each other. Okay, so you might be lucky, you might hit the right two the first time, or you might have to find all three sides and then see which two are equal to each other. Okay, I'm going to find AB first. Okay, so I'm finding the length of AB. So this is going to be the x at A minus x at B squared plus the y at A minus the y at B squared. And then don't forget to use your square root. Okay, and remember I said I write these down here. So A is 2, 3, and B is 5 and 7. So this is a x at A, this is a y at A, this is a x at B, and this is a y at B when I'm substituting. Okay, so AB is going to be the square root of, all right, 2 minus 5 squared plus y at A, 3 minus 7 squared. So that's going to be negative 3 squared plus negative 4 squared. Square root of 9 plus 16. And that's going to give you the square root of 25. So AB is equal to 5 units. Okay. Right, now we need to find another side to see if we can find the equal one. Well, I'm going to take AC now. So I'm going to find the distance of AC. So my formula is going to be the x at A minus x at C squared plus the y at A minus the y at B. Sorry, y at C squared. And then again, I always go back. Okay, A is 2, 3. And C is negative 2, 6. Double check again. 2, 3, negative 2, and 6. Okay. Right, so let's see how long AC is. All right, so we have x at A, y at A, x at C, y at C. Okay, so we've got 2 minus, again, be careful, negative 2 squared. If you're subtracting a negative, you're going to have to put it in a bracket, and 3 minus 6 squared. So that's going to give me 2 plus 2, which would be 4, and this would be negative 3 squared. Okay, so 4 squared is 16, 16 and 9, and we happen to have been lucky and found that AC is equal to AB. They're both 5 units. Therefore, triangle ABC is isosceles. All right, if you found BC and it wasn't the right side, then you keep going until you find the two sides that are equal. All right, then it said find the perimeter. So that the perimeter of the triangle would be AB plus AC plus BC, the three sides together. Okay, I've got these two, but I don't have BC. So I'm going to have to quickly work out how long BC is. So there's my formula. Squared plus the y at B minus the y at C squared. Okay, B, C, again, popping them here quickly so I know what they are. B is 5, 7. And C was negative 2 and 6. Okay, so how are we going to find it? We're going to substitute. X at B is 5, X at C, -2, those two, Y at B, 7, Y at C, 6. Okay, so this is going to be 5 plus 2, so it's 7 squared, plus 1 squared. So this is a square root of 49 plus 1. So BC is a square root of 50. Okay, so square root of 50 is going to end up being, let's work it out, square root of 50, 7,0710. Okay, I'm not going to round it. I could actually rather have used it as the square root of 50 to add into my sum because it would be much easier. Maybe I must do that. So let me take this away and just use it as root 50. Okay, so now let's work out our perimeter. We said just now the perimeter is equal to AB, which was 5 units, plus 5 units for AC, and BC is the square root of 50. And now I can pop this in my calculator, 5 plus 5 plus root 50. And now I can round it to 2 decimals. And it's going to be 17,07 units. Okay, so it's just a more interesting way of using your formula.